Hi, my name is Forrest Olt, and this is my presentation on Chapter 4, Probabilities. Probabilities are used to determine whether or not claims are effective, which can be used, for example, in a medical study or trying to prove a hypothesis. When there's a low probability, chance is rejected, and when there's a high probability, chance is not rejected. This is because we need to be able to attribute results to a claim rather than random chance. So to define an event is a collection of results from a procedure. And the events can be simple or not. So a simple event is an event that cannot be broken down into simpler components. An example of an event that is not simple would be picking up 2 red marbles and 1 blue marble from a bag. And this is not a simple event because there's still the order that it could be broken down into. So, for example, picking up a marble in the order red, blue, red would be a simple event. And then continuing on this example, there's the sample space, and that's all the possible simple events for a procedure. So this would include red, red, blue, blue, red, red, and so on. There's different ways of figuring out the probability of an event occurring. So the first example of how to do this would be relative frequency approximation of probability. And you do this by having the amount of times that a procedure is repeated under the number of times the specific event that you're studying has occurred. So for example of this, if you have where you're trying to roll a dice and you want to figure out the probability of getting 4 on a simple dice. And you roll the dice 100 times. And in these 100 times, you get the number 4 18 times. So finding the probability of getting the number 4 when rolling the dice would be found by putting the amount of times you got 4, which would be 18 times, over the amount of times you rolled the dice 100 times, and this would equal to be 0.18. Another approach is called the classical approach to probability, and this requires there to be equally likely outcomes. So, for example, if you're flipping a coin, and then that's 50-50, so they're both equally likely, and you could use this technique for this. And this is done by taking the number of ways that event A occurs and putting that over the number of simple events. So, an example of this classical approach would be finding the probability of getting a clover from a deck of 52 cards. And in a deck of 52 cards, in case you don't know, there is 13 clover cards. So you would be able to find this by putting the amount of clover cards, 13, over 52, the total amount of cards. And you can simplify this down to 1 over 4, and then that would give you the decimal of 0.25. Third approach I have is subjective probabilities, and this is when you try to figure out the probability of a specific event occurring by estimating it using pre-existing knowledge of relevant circumstances. So if you know when you're driving that you haven't ever been in a car accident before or so, then you can use this information that you have to say, most likely I'm not going to get in a car accident when I'm driving the car. It's basically using your mind to be able to figure out an answer, but it's not necessarily using specific numbers. Sometimes it can be, but not always. Now that we've talked a little bit about how to find the probabilities of simple events, I want to discuss rounding probabilities. So when you're rounding probabilities, you can either give the exact fraction or decimal, but this is a lot of times complicated because there's decimals that can go on for a very long time. So you want to be able to round off the decimals to 3 significant digits. For example, if you had 1/3, if you don't know, if you try to switch this to be a decimal, it goes 0.333333 and just like keeps going. So you would want to move this down to be 0.333, so it would be 3 significant digits. You wouldn't want it to be 0.3 because that's not enough. Another part to discuss is the law of large numbers, which is when a procedure is repeated several times that the relative frequency of an event tends to approach more of the actual probability. And this is a part of why you want to use either decimals or fractions when calculating probabilities rather than percentages. It can also just be difficult to calculate percentages for a long time because it's just not as simple, and using decimals is usually the easiest way of calculating probabilities. Continuing on trying to find probabilities of events, since we covered how to find the probability of one simple event, I also want to cover complementary events, which is the probability of an event not occurring. And this is denoted by a hat, and it shows all the outcomes where event A does not occur. So this can be found by 1 minus probability of A. So in one example, if you're trying to flip a coin and you wanted to see what the probability was of not getting tails, then you could use this technique of trying to find a hat. And this would be done by taking the probability of A, which is 1/2, and subtracting that from 1. So 1 minus 1/2 equals 1/2, and this means that the probability of not getting tails, a hat, would be 1/2. Another form of probabilities is odds, and odds can be either against or in favor. So when actual odds are against event A occurring, this is seen as p hat slash PA, and usually expressed as AB. And actual odds in favor are the opposite, where it's PA dash P hat or BA. Payoff odds is a way of figuring out the ratio and your net profit if you won. So, for example, this can be used in gambling a lot of the time, or like any kind of, games or so. It's usually with money. Or maybe even figuring out the odds of winning the lottery. So, an example of odds being used is if you had a basketball team that has 40 games and they've won 30 of these games. So, A would be the probability of the team winning again the next game. So you would find the probability of this, or the odds, by doing 40, which is the total amount of games, minus the games that have already been won, which that's in favor, and this would equal 10. So then the odds in favor is 30 over 10. You want to simplify, so then it's going to be 3-1. And then in turn of this, the odds against would then be 1-3. This is the over the addition and multiplication rule. This is used for compound events, which is any event with 2 or more simple events. So once again, simple events are anything that can't be broken down further. The addition rule is finding the probability of A or B, and this is found by adding up the probability of event A happening and the probability of event B happening. And then after this, you subtract the probability of A and B. The reason for subtracting at the end is because if the events are jointed, then events A and B can occur at the same time. So if you're trying to figure out picking up cards maybe, and you want to see, can I get 4? And you also want to be able to get a red card, and you want to see, okay, can I pick up a 4 and then a red card or so? There's still the possibility that you could get a 4 of diamonds that's a red. And in that case, the event would be jointed, and you need to be able to subtract the probability of A and B, so it would sort of cancel this out. There is, however, the event of disjointed events, and this is when events A and B cannot occur at the same time, so you don't need to subtract in this case. So putting this in writing a little bit, we have the drawing card example. If you draw a card from a 52 card deck again, and A would be getting a heart, and the event B would be getting a king. So events could overlap in this case because the card can be a heart and a king, the king of hearts. And this means that the event is jointed, and you do need to subtract at the end. In this case, because there is 13 hearts in a deck, you put the 13 over the 52, which is the total amount of cards in the deck. And you add 4 over 52, because 4 is the probability of getting a king, which is event B. So that's event A happening plus event B. And then from this, you need to subtract 1 over 52 because of the probability of getting a king of hearts. And this would equal to be 16 over 52, which then you can simplify to be 4 over 13. And that would be your final answer. The other part of the section is the multiplication rule, and this can be used for the probability of event A and B occurring, or then also the probability of event A occurring and then the probability event B occurring after event A. An example of this would be drawing 2 cards without a replacement. So event A would be getting a jack, and event B would be getting a second jack. So the probability of event A would be 4 over 52, and that's because there's 4 jacks. And then the probability of B happening after event A is 3 over 51, because at that point there's 1 less jack and 1 less card overall. So you would multiply these two to get the probability of event A and B occurring. So this would then be 4 over 52 times 3 over 51, and this would then equal 12 over 2,652, which then can be reduced down to 1 over 222. So complements are getting at least 1 of something. So it could be more, but it has to be 1. An example of this is flipping a coin 3 times, but you want to get a tail at least 1 time. So A would be getting 1 tails, and A hat would be getting no tails. And you want to get the outcome of all the outcomes, basically, of flipping 3 times. And this can be found by taking 2, which is because of the 2 sides of the coin, and then the 3 times that you're going to try to flip the coin. So you take 2 to the power of 3 and get 8. And this would be the total amount of outcomes. And then you get the probability of all heads. So this is only 1 out of 8. You would take the probability of to get the probability of at least 1 tail, you take 1 minus the probability of A hat, which is the probability of getting all heads. So this would then be 1 minus 1/8, which would be 7/8. So then altogether, your probability of getting 1 tails from 3 coin flips would be 7/8. So conditional probability is a probability that's found with additional information of another event that occurred. And this can be the probability of B/A, so the probability of B occurring given that A already occurred. And this can be found by taking the probability of event A and B and having that over the probability of just event A. Bayes' theorem is for revising probabilities based on new information, and the formula for this would be the probability of event B happening before event A multiplied by the probability of event A over the probability of event B. This has the multiplication counting rule, which is used to find the total number of possibilities from a sequence of an event. So it's usually found by taking event A, all the possible ways that happening, multiplied event 2, all the ways that can happen, 3, and so on. So an example of this would have a stack of cards and dealing 1 card out to each player. The first player can have any one of 52 cards because there's 52 cards on deck, but then player 2 can only have 1 of 51 cards because obviously 1 card has already been given to the first player. So to be able to find all the possible ways of dealing out this 1 card, you would take 52 multiplied by 51, and that would equal 2,652, and that's all the possible ways of dealing out 1 card. The factorial rule, and this is the total ways n different items can be arranged. And this is usually denoted by exclamation mark. So for the factorial rule, if you're arranging 5 books on a shelf and wanting to know all the different ways that you can arrange them on the shelf in the order, then this would be a permutation problem, which a permutation problem is different sequences of the same item counted separately, but then for combinations, that's them all being counted the same. So these are all being counted differently because it's all the different books. So to be able to find this, you take the 5 exclamation mark because that's showing all the different ways that the 5 books can be arranged. So basically what the exclamation mark means is 5 times 4 times 3 times 2 times 1. But obviously if you have a calculator, you can just put the 5 exclamation mark in. And this equals to be 120. So in the case that it is not a permutation problem and you're trying to figure out the combinations rule, which like I said, combinations are being counted as the same. So an example of this would be instead if you had 7 different books and you want to choose 3 books. So in this case, the order doesn't really matter because you're just wanting the 3 books. It doesn't matter what way it's arranged on a shelf or so. And you'll be able to figure this out by n exclamation mark over r exclamation mark n minus r exclamation mark. So in this case, it would be 7 because of the 7 different types of book, exclamation mark over 3 exclamation mark in parentheses, 7 minus 3 exclamation mark. Then this would then equal to be 7 exclamation mark over 3 exclamation mark times 4 exclamation mark. You put this into a calculator, it then equals 35. You can also do the technique once again where you count it down to like 7 times 6 times 5 times 4, but I think it's usually easier to use some kind of technology. And simulations are a process behaving the same way as a procedure would, so you can get similar results. And it's because it really ties into probability, because a lot of the time when you need to find probabilities is for some sort of study and you're testing a hypothesis or so. And when you're testing a hypothesis, you might want to figure out what's the probability of an event occurring. So you do a simulation to figure out what would happen before the procedure actually happens, so you know what to expect. That's all on Chapter 4, Probabilities. Thank you for listening.